Hi, and welcome back to another AnyRPG Development Livestream. In these videos, I livestream the development of the AnyRPG Engine, a free and open source role-playing game engine designed in Unity and written in C#. These videos are unscripted and give you a chance to take a behind-the-scenes look at the unfiltered, methodical side of software development. For more information on AnyRPG, you can check out AnyRPG.org, where you can find documentation on the engine, links to the full source code at the official GitHub repository, and downloadable versions of the AnyRPG Engine in Unity package format, as well as free playable games designed to showcase the features of the AnyRPG Engine. If you like this type of content and you'd like to see more of it in the future, then don't forget to subscribe to the Cohesion YouTube channel, thumbs up the videos, or just leave a note in the comments telling me what else you'd like to see. In this video, we will be continuing our work getting ready for the 0.7 alpha release. And last time, in the last episode, I was having some trouble with NavMeshAgents, and I have gone through and spent a considerable amount of time sort of troubleshooting and debugging that, and I just wanted to show basically the results of what I found and what I did, and how that improves the NavMesh agents. So right now, I'm in the game and I'm sitting here in the dungeon, and one of the issues that I previously had was that if my guys were in combat, and my character moved, then the guys would basically come running toward my character and try to follow him rather than continuing to fight whoever they were fighting. So I'm just going to open up the AI controller here, which is where I believe I actually changed this code a little bit here. So we'll load this up. Okay. So in set master relative destination, what I've done is I've checked if the character's in combat, and if they are, then they've got a different max distance that they need to check. So basically, if you're in combat, I have to move more than 15 meters away from my pets in order for them to follow me. Otherwise, they'll follow me as soon as I've moved 3 meters. And previously, what was happening was when I set this master relative destination, I was setting this every time the master moved, and this was leading to an issue where like my pets wouldn't follow me because they were continually recalculating their paths. So what I did basically is I just checked if I changed the code to basically do this right here. So if the distance between the pet's position and the master's position is greater than whatever our max distance is currently, 3 or 15 meters, and the distance between the pet's last position that we told him to go and the master is greater than the used max distance. And this check right here is really important because it means that instead of just checking if we're far away from the master, which would actually cause us to basically recalculate our destination every frame, we're checking the last position we were told to go to, which could be right beside the master. And if the master hasn't moved 3 meters from the last position that we were told to go to, then we just won't bother doing any calculation. And that has a really big benefit in that our pet will only get a new order to move if the master is more than 3 meters from where we were last told to move to. So not every frame, basically. The master actually has to move more than 3 meters or 15 in combat. So I just wanted to demonstrate that because here in this fight, this is actually a really important concept. So we're in the dungeon, and basically we want to make sure that when we fight the final boss here, that we're able to run around freely and cast on him, and that our pets will basically keep on attacking him. Because if they run over to us when we move, they'll drag the boss over to us, and then he's going to hit us with his AoEs, and we don't want that. So let's just test this. So I'm going to hit the Earthborn Troll with an ability, and then I'm just going to basically run around. And you can see my mobs are fine, they're fine, they're fine. I move 15 yards, now they start moving towards me, right? So that's good. Basically, as long as I sort of stay half decently close, then they're going to keep on fighting him pretty much. So I can just let them take them out. I can run around as much as I want, and now they're not following me. Cool, so that worked. So that new code, basically it works a lot better now. Unique, interesting. I got 2 unique drops off of that one. Ooh. And I think we need to let our pets take this guy out and just run out of here ASAP. Alright, let's complete that. We're just going to leave our pets to deal with that guy right now. Run back here. Yeah, we can see him on the radar. He's coming in hot behind us. Run. Alright, let's see. Do we have any more gear we can equip here? Yeah, cool. Some better armor. Alright, and teleport out now. Alright, sweet. So, we're safe. The next thing that I wanted to demonstrate, actually I'll take this guy back to the base here, and then I'll show how I dealt with the problem with the rabbits, basically. So when it comes to the Unity NavMeshAgent, there's a lot of little quirks that it has, and if you just sort of like throw a NavMeshAgent on and it constantly tell it to like reset its destination and stuff, it's going to perform really terribly. And there are a bunch of tricks when you're working with levels that are sort of hacked together the way I've hacked this one together that you might have to do. And I'll show you some of those tricks here in a second. So let's just save the game, and then we'll pop out to the main menu. And I will pop on to my Ranger character here. So let's go on to my Ranger. Actually, you know what? Yeah, no, Ranger's good. Okay. So we'll jump onto the Ranger character. And I'm just going to hop on my mount here because I've got a dragon mount, and this helps demonstrate as well sort of the improvements that have been made with the Pets NavMeshAgent system. So we're going to go over to Birch Grove here. And let's just go run out of the base here and take a look at these bunnies. So what you're seeing right here is basically a component that I placed on the bunny, and this is actually a really helpful component. And let me just show you that one. So if we go to the cute fluffy bunny unit and we look on him, he's got a new component called a navigation debugger. And this navigation debugger is like a super simple script. Basically, the only thing it does is just make like a line renderer, and then makes line renderers for pretty much everything in his path, his NavMeshAgent path. So what this means is that so long as he has a path, then you'll just see these little pink lines showing where he thinks that he is supposed to be going, pretty much. And so one of the things I noticed, actually a couple of things I noticed, was basically the bunnies were getting stuck. And I'm just going to let this bunny run around for a little bit here and see if I can actually demonstrate how our stuck avoidance is now working. Actually, let me get on my dragon, and I'm going to go over to a different different bunny, because there's a bunny over here that gets stuck in some, or that used to get stuck in some really interesting ways, and I'll show the code that I wrote for how I'm avoiding this from happening again. Okay, perfect. So this bunny over here, he's running around. And if we look at this hill here, this hill is really steep. So let's just actually pause the game here and go into the scene view and take a look at this. So I am going to focus on my character here. So we'll go to the player units and hit F. Okay. And then we'll hit the navigation tab. So what you can see here is basically I've got a hill, and the hill has some nav mesh on it, and then at some point it just gets too steep to climb, and we can't have the nav mesh working anymore. And the bunny basically used to get stuck here all the time. And last time when I was testing this, I found that after I had more than 5 bunnies on screen, that all of a sudden they just stopped respawning and their NavMeshAgents weren't working. And I did a bunch of debugging and found that it was taking like 300 or 400 frames in order for them to actually calculate their path. And there's a really good reason for that. Now basically what I've done in this level, if we just zoom out and look at the big scene right here, is this level was patched together from 3 different levels. So let's just take a look at those individually. This right here is the bandit camp scene that makes up the mouse base. And if you look at this bandit camp, and then we look down below the ground, you can see that although I have the Birch Grove terrain here, I've got the bandit camp terrain literally poking right through it and coming underneath. So this means we actually have 2 terrains on top of each other. And what you can see here is that on the under terrain, it's actually a valid nav mesh, and there's really nothing that we can do to stop that. It's always going to have nav meshes on this terrain underneath. And when I was previously sending a character in a certain direction, what I would do is I would basically start, I would ask the character to go to a certain spot, and then I would have it expand a sphere outwards looking for a valid nav mesh near that spot until that sphere got about 3 meters big. And what that was actually leading to was a case where the sphere, say for example if the character wanted to go, actually I'll find a really good place where I can demonstrate this pretty much perfectly. Yeah, right here. Okay. So if my character's sphere landed over here on like a hill with no walkable material, like let's say right here, right around this point, then what would happen is as the sphere expanded, the Unity NavMesh agent actually prefers downwards rather than sideways, which means that it would actually end up expanding the sphere, totally ignoring all this stuff over here, and then hitting this mesh below, and then trying to calculate a path down to this bottom level. And since obviously there's no connections between this sort of hidden bottom level and the actual top level, that meant that the Unity NavMeshAgent was taking several hundred frames while it basically expanded its pathfinding algorithm to cover the entire map to try to find a way down there. And when I had like 5 bunnies, all 5 were doing that. And Unity actually calls your number of NavMesh agents or operations per second if you reach the maximum number of operations. So let's just show that there. I think I do that in the level manager. So you can use this setting right here. The default is 100 pathfinding iterations per frame, and I set it up to 500, which means that it will do 5 times as many pathfinding calculations per frame. So if you've got like a bunch of units on your screen, this is probably a good thing, and that way they won't basically get their pathfinding called and just dropped and just sit there and do nothing. So the other enhancements that I made, and you can see basically actually this whole like dual or triple nav mesh issue. If you look over here, this whole nav mesh off the side of the level here is like sort of hidden underneath this one. And then if we look over at the graveyard, this cemetery here was another level that I imported, and I wanted wanted the ground, and it's not possible to cut nav meshes. So you can see how the cemetery ground here starts out here, and then you can see the other ground basically go underneath it. And you can see actually the same thing over here on the humans camp. You can see that I've got this ground from the camp sort of intersecting the other ground basically, and you've got like this bottom ground layer right here and then this other ground layer here. And this was also leading to all sorts of problems where you'd get like the character would try to hit the nav mesh right here, and because there's a blue spot underneath it on the ground, he would try to go down there. So what have I done to fix that? Well, that is going to be shown here. Let's just find somewhere where we're actually setting our destination. So when we go to set destination, rather than just having a single sphere expand outwards, I'm doing a bunch of stuff now. So I have this corrected nav mesh position function, and let's go to the definition of that. So what it's going to do basically is whatever random position my units choose to move, and let's just return back to the example of this bunny here. So I'll hit F on my character. Let's say my bunny attempts to run up here, right on this hill. Well, what it's going to do is it's going to do a NavMesh sample position, which is basically a sphere cast with a 0.5 meter radius, and try to find the nearest edge. If it doesn't find the nearest edge, then what it's going to do is it's actually going to do a downwards raycast from like 10 meters above and try to hit something. And there's a really good reason for this, and I'll show why if you look at the land here. So basically, let's say the bunny is pretty much where my character is, right? And he chooses a random point, like right here, inside of this hill, right? And let's say he chooses the random point right here. Well, if I just do a sphere cast from here, I'm not going to find anything. It's going to hit nothing, right? But he needs to not get down there onto this bottom level, which means I want to make sure that the next time that I try to find a nearer valid position for him, that it's on the top ground. So basically I'm doing a ray cast downwards from 10 meters above the ground to try to figure out if like I'm at the top of a hill or something. And if my ray cast hits something that matches my ground mask, which is basically like walkable, then I've found a match, and then I'm allowed to start my sphere cast outwards from that radius. If I hit something with the NavMeshAgent sphere cast, then I'm going to return that position. If I reach the maximum sample size, which in this case is a 3 meter sphere, and I haven't found anything, but I actually did hit some walkable ground, I'm just going to return vector 3.0, which basically is an invalid position that tells the agent, just go ahead and ignore any commands that happen this turn, and try again next turn with a different random position. If I didn't hit a hill, then I'm allowed to raycast downwards. And the idea is, let's say my character's here, he chooses his random position in the air down here, he does a raycast from 10 meters above, he didn't hit anything, that's cool, so he's not beside an uphill, so he's not going to try to go inside of a hill. And then now I will raycast from this point 10 meters downwards to the ground, and then if I actually hit a walkable surface, then I will also expand my NavMesh sample position outwards to a 3 meter radius to try to find some ground that's connected to a NavMesh. And by having basically this this first raycast down from 10 meters above, or sorry, the first raycast at exactly the position with a 0.5 meter radius, if it doesn't find anything, then doing it from 10 meters above, and then attempting from the current height down to 10 meters below, you should end up in a position where no matter what you choose, it's a valid position. In other words, if there's a hill here, you're not going to end up raycasting downwards from the middle of the hill, miss the fact that there's ground above you, and end up trying to tell your NavMeshAgent to move to this invalid position down here. So this code is all pretty useful, and it's in character motor. You know, you can look at that on GitHub if you want to see how I'm doing it. But it's led to just a lot better movement with the character. There's a couple other enhancements basically that I made. So when your character is patrolling here, there is one instance, and I'll just zoom over to another part of the map that I found, and this is like another sort of like NavMesh edge case, and that's actually what most of this code for, is actually just dealing with like strange edge cases for like weird terrain geometry, where your characters could pretty much just get stuck. So let's find that rock. It's this one over here, because this bunny kept on getting stuck doing nothing, and I'll show you exactly why. So what would happen is the bunny would basically choose a spot like right here where I'm sort of circling my mouse around. And although this is technically on the nav mesh, it's not a wide enough path for the bunny to actually walk up there. So what would happen is if you have an invalid path on your NavMeshAgent, and I'll just pull up the bunny here so you can actually see this. So we'll grab one of these bunny units, and we'll look at its inspector. And you can see that on his NavMeshAgent, he actually has this thing called auto repath. And what that means is the minute that he detects that it's an invalid path, he'll try to create a new path for it. And because it's on the nav mesh, it'll actually create a path, the same path that it did the first time, which is basically sort of a path that went up this hill here to this point, figure out that it's invalid, and then just do the whole thing over. And he would literally just get stuck in a loop, standing there doing like absolutely nothing. So I actually added some code to detect this, and if we stand around for a little while and actually watch these bunnies walk, you might see occasionally he'll blink up to a spot that he can't get to, and then you'll just see the pink line like disappear really fast. You kind of got to stand around for a while to actually catch like an instance of this happening. But if you look at the logs here and at the console, what I've done basically is, if we couldn't find a valid position, we return vector 3.0, and the character just ignores it. If basically, yeah, there it is. I'm just going to let the game actually run for a little while longer, because there's another error or log message here that I actually want to show you. And you just, eventually, you'll sort of get lucky and the character will actually pick a position that is a valid position on the nav mesh, but that doesn't result in something that's actually like properly pathable. And this bunny over here by the rock is the most likely one to do it. Usually I only have to leave him turned on for 2 or 3 minutes in order to actually see a case of this. There we go. I think it just happened. Perfect. Okay, so I don't know if you noticed, but there was a really quick point here where the bunny made like a flash of pink on the corner of the rock, and it just disappeared, and then he just made a new line over and ran over in the other direction instead. And if you look at the logs right here, this is what happened. So basically, your NavMeshAgent has a path status, and if you set that path, if the path status basically, like, you'll see a pink line, which means he actually has a path. And he was able to calculate basically a partial path. So if we go into the scene here and we look at this rock, let's say for example, this is where the flash occurred. Well, he could actually create a path that went like here and then here and got basically that far, but then couldn't make it the rest of the way, at which point the path status became partial, meaning that he could only get halfway to that area on the nav mesh. Because of auto repathing would cause a partial path to actually get recalculated. And so what would happen is basically he would just stand there recalculating the same path every frame. So instead what I've done is, in the code basically I'm detecting if he has an invalid path or a partial path, which pretty much meant that we got a spot on a nav mesh, but we just couldn't navigate to it even though it was on the nav mesh. And if that's the case, I'm setting this get new destination flag to true, at which point he's just going to grab a new destination instead. If we don't do this, he's actually, his NavMeshAgent will just keep on getting stuck in a loop trying to repath to the same place over and over and over again. And that's why my NavMeshAgents were basically behaving like so flaky before. To demonstrate that the pet following you around thing works, like really works, I'm just going to charm this pet right now. And I actually used to have problems with him because he wasn't like following me properly, basically. Like as soon as I'd start running, he'd just stand there and he'd wait till I stopped moving before he was actually following me. And this is that code that I put in place that basically checks like, hey, has the player moved more than 3 meters from the last location that we were told to move to? If not, then don't issue a new command. Because if you literally, if the character every time he moves, if you issue a new command every time he moves, instead what the bunny will do is just literally spend every frame recalculating the path, and since paths take a couple frames to calculate, then he'll never actually get a complete path. This actually works fine pretty much like no matter how fast your character's going. So you can see my bunny here is having like zero problems keeping up with me at all. It doesn't matter how fast I'm going because basically he gets to have a path until I'm more than 3 meters away from it. Also, his movement speed is automatically set to my movement speed, so even though I'm on a dragon, you can see he's like super zoomy bunny now, right? And then if I jump off the dragon, actually, and the funny thing is he's so fast that sometimes he actually overshoots his destination. But you can see if I jump off the dragon, then he's just also matching my run speed at whatever speed I'm at. So between all of those enhancements, just the extra ray casting up and down and all those calculations around there, plus the whole you have to move a certain distance from your bunny and the invalid and partial path recalculations, the NavMeshAgent system seems to actually be working really good now. So I haven't had any problems with it, and that's pretty good. These guys are pretty much not getting stuck anywhere anymore. They don't do weird things in combat. So the next thing that I wanted to do is another sort of performance enhancement, and let's just demonstrate what the issue is here. So I'm going to jump out to the main menu, and I'm going to jump on a character who's at approximately the right spot that I can demonstrate this here. I had another character here just for NavMesh testing. Let's see if we can get any more gear. I'm going to take this 8-slot bag, unequip it, equip that 20. Okay, perfect. Now I think I'm wearing all the gear that I got dropped. Okay, good. So let's go get the quest on this guy to go help out the knights. And the best way for me to demonstrate this is actually to go to the traveling salesman. I'm going to cheat a little bit. I'm just going to buy an ability that's not available as part of the regular quest chain. And this is the condensed elemental death. So condensed elemental death has the ability to give me an AoE life tether, and this is like more of an endgame ability, but for the purpose of this demonstration I'm just going to cheat, buy it off our GM vendor, and then go demo it. Because I think I can actually cause the next target, I guess, for performance enhancement here to show up pretty easily. So what you're going to notice probably is everything's running fine. It's pretty smooth, you know, I can jump around, I can like spin while I'm jumping, I can like orbit my character, things are working pretty good. I pick up this quest here, and we get a quest to get some Goblin Rangers, and we head over here into the battle. And things are still going fine, you know, there's lots of people, they're fighting, the performance is pretty okay here, and now let's just kill our performance a little bit. So I'm going to hit this AoE life tether. There we go. And you see that lag? Every few seconds there's a little bit of a pause where everything on screen sort of just freezes up. Let's see if I can demonstrate that again. Okay, I think I actually have to have like a few more guys here. So let's just loot these guys and try to get some more respawns. And we'll see if we can get this to happen again here. So we just got to get these guys all looted here. I'm just going to destroy this damaged bow, and this should help me loot some more of them. Alright, and now they should start respawning. Perfect. And let's try this life tether AoE again. Okay, it's not, I was kind of hoping for a little bit more. Sometimes it gets really, really obvious, but basically what the problem is that when you're AoEing these guys, every time that your life tether hits, it's going to spawn a bunch of text objects. So some of these text objects are healing objects and they spawn over top of our other characters, and some of these are damage objects and they're going to spawn. Actually, you know what? Let me just pop out, because I think what I can do here is I can pop out to the main menu, and now that I'm in the middle of this battle, if we just log back in, everything's going to respawn. And if I hit these guys with an AoE right at the beginning, we should start to see the lag here. Perfect. So there we go. Lag, lag, lag. Oh yeah, frame rate's way, way, way down. You see that? Frame rate's just like dropped, and the game just like almost froze up for several frames at a time. So this is because basically Unity doesn't seem to be able to handle the creation of more than 5 objects simultaneously. So what this means is that every time that we're popping up a combat text, we're actually instantiating a new combat text object, and then we're destroying them, and then we're instantiating them again. And there is a technique basically called object pooling that you can use in games. So instead of getting this terrible lag and freeze up here from the instantiation and deletion of all these objects, we can basically just create them in advance and enable or disable them, which should give a much better performance because Unity doesn't have to actually go through and be creating these things all the time. So to do that, we're actually going to have to add an object pooling mechanism to the combat text, and that is going to mean writing some code. So let's just look at where or how our combat text is instantiated right now. So we have a combat text manager, and at some point it's going to instantiate a combat text prefab. So let's go look at that. It's also going to parent that thing to the combat text canvas.transform. So if we go into our alpha load game manager and go to our UI, and this is our interactable UI and player UI, and it's somewhere, I think, actually in the, yeah, there we go, the information display, and we've got this combat text canvas here. So if you look during the game, we're going to have a whole pile of combat text spawned under here. So let's just go check that out. So we're going to load up our game again. We're going to go into this NavMesh tester here. We're going to hit load. And let's just see how many of these things we can get popping up. So we want lots of healing, lots of, okay, perfect. So now we have a whole pile of them. Let's see how many we've got there. Whew, look at that. Wow. Wow. Holy. 372 objects. So Unity basically just had to instantiate 372 combat text objects in that scene, wow, over a period of like 2 seconds, and that's where all that lag is coming from. So what we want to do instead is we basically want to pre-create all these, and we just want to have the game basically turn them on and off as needed. So let's do that. So what we're going to do basically is we're just going to actually hold on, let me just undo that for a sec, because what I want to do is I actually want to go right into the actual game manager prefab itself here. And there we go, that's better. And then we can go to the interactable UI, player UI, information display, combat text canvas, combat text. Okay. this is going to take a little bit. Okay. It's basically the quickest way to do this is just going to be shift on this and duplicate every time. Okay, so now we're up to what, 24? Alright, we got 48. 96. Alright, so now I have 192 combat text objects. I don't honestly know what's like a good limit for this. I think what I should do is just basically start deleting stuff after we get too many of them. I'll start with 192. I might actually drop this downwards. Honestly, I think if you have like more than 100 of these objects on screen at a time, it's probably going to make your screen pretty like hard to see anyway. So for now though, I think I'll just test that and we'll just deal with 192. So what we need to do here basically is we need to have in the start method of the combat text manager, we're going to go through and we're going to find all of our combat text objects. So to do that, we'll go public void start, and we'll get a list of game object called found objects equals, and this is where we're just going to get, I think we just need to search our children here. So what we want to do is basically search our combat text canvas. So combat text canvas dot transform dot find children. Just a second. Unity get all children. There's a really easy command to do that. I just forget what it is. I thought there actually was. Oh, there we go. Perfect. Yeah, for each transform child in parent. Perfect. That's actually pretty much what I want to do. We don't even really need tags though. So for each transform child in, I think we just do combat text.transform here. Yeah. If, and actually what we should do is I actually want to keep a list of the combat text objects. So we'll make a private list of combat text controller, which is the actual controller that lives on these objects. Let's just go take a look at that. Yeah, combat text controller right here. Perfect. So we want a private list of combat text controller, combat text controllers, and that equals a new list of combat text controller. Right, because I need to remove those. Okay. And so if, actually first thing we'll do is basically combat text controller equals child.get component combat text controller, and if combat text controller does not equal null, then we are going to do the combat text controllers dot add combat text controller. Okay, great. So next what we need to do is when we go to spawn the combat text, we pretty much just have to get the object off a list. So what we need is actually a second list of combat text controllers called in use combat text controllers. And this is where we'll basically move our things to. So here, instead of instantiating an object, what we'll do is get one from the list. So to do that, we'll need a new public combat text controller, get combat text controller. Sure, why not? And we will basically grab one off of the list. So if combat text controllers dot count is greater than 0, then what we are going to do is we're going to do in use combat text controllers dot add combat text controllers 0. I'm going to set the return value to null and return the return value at the end. The return value is combat text controllers 0. Then we add that to the list, and then we take the combat text controllers dot remove at index 0. So this will grab the 0th element in our list, which is the first one, add it to the combat text controller list, set it as the return value, and or add it to the in use and remove it from the combat text controllers. Perfect. So otherwise, what we're going to need to do is we're going to need to take one of our combat texts and reuse it. So to do that, it'll be a different piece of code. So what we will want to do is return value equals actually if in use combat text controllers dot count is greater than 0, because it's quite possible that maybe somebody goes into the prefab and accidentally deletes everything and there's no combat text controllers at all. But basically, if in-use combat text controllers.count is greater than 0, then return value equals in-use combat text controller 0. Then we actually want to go in-use combat text controllers dot remove at element 0, and then we want to actually re-add it back. So in-use combat text controllers dot add return value. Okay, good. So what this will do basically is take the item off the beginning of the list and just pop it to the end of the list, so we're not constantly like reusing the same element and just deleting and recreating the same text. We want basically all this text to stay on screen for as long as it needs to until other stuff replaces it. And basically that's it. That is the code that will get our combat text controller. So instead of instantiating it, we need to do something slightly different here. So we will call get combat text controller instead. No, what we will do is we'll do combat text controller equals get combat text controller. Okay, and if combat text controller does not equal null, then we can do the rest of the stuff right here. And so this will be combat text controller dot game object. Actually, you know what? We don't even need the game object, I don't think, to be honest, because nope, we don't. All we're doing is basically using it to get the combat text controller. So that's a lot easier. Basically, we can just do that. Oh yeah, also these probably weren't very performant either, because they're also get component calls, which I don't think is something you want to also be doing several times per second. So then we pretty much just resetting everything on here, and that should be okay. We'll need to do the same thing here, pretty much. So we'll just take all this code, move it inside there. Comment that out. And replace all these get component calls with the reference to the combat text controller. Okay, good. So now we have our damage and our lose buff and gain buff stuff all set, and everything should properly be using the right objects from the object pool. So there's one last thing that we have to do, and that is basically we need to return combat text controller to the pool. So when the combat text controller is done, public void, done displaying and is about to destroy itself, we need to fix that. So we will go to combat text controller, go to definition, and then there's a spot like way down at the bottom here, there. So instead of destroying it, basically what we want to do is do combat text manager dot my instance dot return controller to pool this. And then what we'll do in here is basically if in use combat text controller dot contains combat text controller, in use combat text controllers dot remove combat text controller. And then we want to do combat text controllers dot add combat text controller. And finally, combat text controller dot enabled equals false. And when we get the combat text controller, you know what we actually want? We want to enable the game object. Right, no, we actually want to do set active false. That's better. We actually want to disable the game object. Okay, good. So then here we want to do return value dot game object dot set active true. Okay, perfect. So what we'll be doing is setting this thing active, returning it. You know what? Actually, I don't want to do that here. First I want to set all this stuff, and then I want to set it active. Actually, I may even change that as well. Because basically I don't want to set this thing active without having actually the text correct on it, because it might display the wrong text for like a single frame or something like that. Let's just go into the combat text controller and see how it's set to do this, because pretty much yes, this is our start method. And then fixed update. Okay. So what's in this start method here? We actually need to make this to like an initialization method. So this is going to be a public void. I'm just going to call it initialize combat text controller. And we're just going to copy all the move out of the start here. And pop it into here. Good, so at least now it'll be, I think, at the correct position. Let me just make sure we're actually setting the position. No, we're doing that in fixed update. Okay, so what we'll need to do actually is call initialize combat text controller, and then follow that up looks like we may actually even have to reset the alpha on it as well. Because of the fact, because of the fact that we're setting the alpha down. In these ones. Okay. So basically here, instead of setting it to text.color.a, I think we actually just need to set alpha equal to 1. And then we'll actually want to run the first update loop. So we're going to create a public void. Doesn't really have to be public, but it's okay. And we're just going to call it run combat text update, for lack of a better one. And this is run combat text update. We're going to remove all that code right there. Put it in there. And then at the end of all this, we're just going to run the combat text update in order to actually get this stuff where it needs to be on the screen. And then continue running it every fixed update. Perfect. So this is initialize combat text controller. Good. So then we can go back into our combat text manager, and actually this is where we actually want to set the game object to active. So we'll set it active here, and then just call our own game object.setActiveTrue. And this gets to be replaced with .initialize combat text controller. Perfect. So we'll set all this stuff, call initialize, at which point it will set itself active. When we return the controller to pool is when we're going to set it to inactive. So just looking down here at the very bottom, else return to pool this. Perfect. So this should result in a reusable recycling object pool for our combat text that hopefully won't result in these crazy pauses from all those get component calls and all of that object creation and deletion constantly when we're dealing with a ton of combat text in our game. So we're going to save that, and now let's try this again. We will go save the game, pop out of the game manager, into the alpha load game manager, press play. Load up our no, I totally don't. I think, yeah, it is this guy. This is the right guy. Okay. NavMesh tester was the guy I was using. Good. So here we are in the middle. We're doing combat. Whoa. Okay. We have some issues here. Let's figure those out. So, all right. So text wasn't set. Okay, let's just go take a look at these. Oh, no wonder. Okay, so let's just open up our combat text prefab here. Well, that's interesting. So the combat text prefab that I copied, I think let's open this up here and open this up here. I think I copied an improperly configured combat text prefab. There we go. We want to revert that. I don't think we can revert over a mass of things. Oh man, no, we can't. Well, isn't that silly? Okay, there's no way to do that except individually, which literally means I think I need to delete all these things in order to actually fix it. A little bit ridiculous that you can't mass revert, because of course it's configured fine internally, so there's really nothing I can do about that. Okay, so fine, I will delete all my combat text prefabs, and then we're going to revert that one to the standard fade time, and we're going to duplicate that, duplicate those, duplicate those, duplicate those, duplicate those, duplicate all that, duplicate all that, alright, and now we have 256 of them. Okay, 256 will be fine for now. If it's too crazy, I can just remove a few. So, let's save that. And jump back out to the alpha load game manager. Just take a look, make sure these are all set up properly. Good, they look like they're fine. So let's press play and try that again. So we can load the game, go to our fighter, our NavMesh tester, hit load, and let's shoot out our AoEs. Interesting. Wow, okay, so we have a few bugs here. First is that the combat text size kept on getting reset. And the second is that the object pooling really didn't seem to have any impact at all on performance, which I'm actually a little bit surprised about. I thought we were going to get a lot better performance out of that. So, first, we need to reset this stuff. So, I don't think we actually track a default text size here. So let's see. I think that's something that we actually want to add then. So if we open up our combat text controller, look at our default font size is 30. So we'll just set that as a serialized variable. 30. And then here we need set text dot font size equals default font size. And this way, every time we reinitialize these things, we should end up with the font size getting reset properly. So let's go in and try that again. And we will save the game and press play. We'll load up our NavMesh tester here and hit that AOE button. Okay, that's a little better. I think basically what I was noticing, whoa. Yeah, okay, I was destroyed by the goblin, totally. Huh, interesting. So what I'm noticing, I'm actually noticing a little bug right here, and that is my NavMesh tester is allowed to regain health from his out-of-combat regen while he's dead. That totally shouldn't be happening. In the meantime, though, what I do want to do is I want to run that again, because it looks like we actually did have a little bit of improvement this time. It looks like humongous text, for some reason, tends to cause a little bit of a lag. Ooh. I wonder, you know what I'm thinking? I'm thinking, what would happen if I made a whole pile of combat text canvases instead? Because I just realized that what's happening is that every time that anything on a single canvas changes, it has to update, like redraw the entire canvas. And I bet you that has something to do with the lag in there. Let's just load it up again, and I just want to take a look at how much the performance has improved, because I did definitely notice some performance improvement. We're not lagging as bad anymore, although there is still a little bit. So yeah, that was a lot better, I think. I didn't die that time either. Let's try that one more time. At some point in the future, I think I probably will make a bunch of canvases. I'm not sure if there's any performance implications to having like 200 canvases. Like if there's a maximum number of canvases that Unity can successfully handle or something like that. But yeah, I'm not seeing the lag nearly so much. A couple other issues I noticed. First of all, A, out of combat regen, but B, my character was actually still casting while he was dead. Kind of interesting. I may not have a stop casting on that. Let me actually just revive that. I wonder if it's possible to just get my character killed. Yeah, now I can't actually get anyone to come after me here. Let's see, maybe this guy. Nope. Oh, the mice are going to take him out too quickly. Okay, you know what? This guy can kill me. Okay, perfect. I want to see what happens if I die like mid-cast. Does he get hit with the solar singe? There we He did. He totally did. My character actually completed the cast before the death. Okay. So we know that the combat text object pooling works. So why don't we just go fix that. The other thing I'm going to do is actually I'm going to go to the cute fluffy bunny unit, and I'm just going to remove this navigation debugger, because basically we fixed the navigation on the bunnies, so we don't need that drawing pink lines on the screen all the time anymore. So we'll save that, and then yeah, we can just throw this in there because this is just like a reformat. It can go in the same commit, just extra tabs and stuff. So we're gonna git add -a everything and git commit -m, add object pooling to combat text manager for improved performance. Perfect. So that's done. We got our object pooling done. Quite happy about that. And then now just let's go look at that attempt out of combat regen code. So that's going to be in, I believe, yeah, it's either character stats or character combat. I think character combat. Okay. And base character dot my character stats dot is alive equals true. We should not be able to enter the out of combat region if we're dead. Let's find all references to where we actually enter that, and that's right here. So and base character dot my character stats dot is alive equals true. Okay, good. So if we find all references to this, this is the entry point to attempt regen. No matter where you are, you attempt regen this way. Perfect. Okay, so that is hopefully problem number 1 fixed. Let's go get our character killed again and just make sure that they're not doing out of combat regen while they're dead. So we'll go to our NavMesh tester. Ooh. Okay. Wow, that's really interesting. Okay, just a second. So we attempted regen on what? We spawn the player connection. Oh, interesting. I see. Okay, neat. Basically, we're attempting to attempt the regen in the onEnable method. I don't really think that needs to be there, to be honest. Player combat lives on the player connection. So we're not really going to be disabling it except for when we log out. We're only going to be enabling it when we log in. I think start would actually be a better place for that, or at least somewhere after we've gotten our component references, because right now we still actually don't have a reference to character stats. So I'm just going to remove that from there. Now obviously you sort of do want it to happen on login, so let's actually just take it and move it up to start. You know what? There it is. It's already in start. Good. Pretty sure by the time we run start, we'll actually have a reference to our base character and our character stats, because all that stuff is done by the orchestrator, like sometimes during the awake calls. So let's just try that. Okay, that's a lot better. Okay, good. So now what I want to do is I want to get myself killed. Perfect. Now, my character's still casting, and that's a problem. We definitely need to fix that. However, I am not doing out of combat regen. Perfect. So, no out of combat regen, good thing. So let's just fix that. And out of combat regen was actually its own change, so we're just going to add that as its own individual change. Commit that. And now we're not going to refill the health on our character when we're dead. Okay, great. So next up we need that last fix, which is I am dying, I need to stop casting. So that is going to happen somewhere in Character Ability Manager. And I'm not sure, but we may already be subscribing to the on-death method in here. If we're not, we should be. There we go, on die handler. Huh, look at that, and that's all we're doing. I want to go to implementation of this, and we're not overwriting it anywhere. This my waiting for animated ability, that's already handled in the method we actually should be calling instead. Let's find all references to that. Let's see where else we set it. Level and load, no, okay. Set in clear animated attack. We set it in drop combat. We set it in cast. What I'm actually looking for, let's just find out references to clear animated attack. Clear auto attack. Clear animation blockers. And find all references to that. Stop casting. Yeah. Okay, good. So basically, that's all we need to do. We just stop casting. So we'll go back till we find that onDie method where we were. Go to the definition there. And just call stop casting instead of setting that directly. Okay. So let's try that out. File save, press play. Load game, load up our NavMesh tester, and zapify everybody, try to get aggro, see if we can get ourselves killed. Oh yeah, we're getting down, and we stopped casting, and we died properly. We're on the ground. Our character is not doing out of combat, and awesome. There was no more AoE life tether happening. Perfect. So, I think we fixed it. Let's just try that one more time. We're going to play, we're going to load game, we're going to go down to our NavMesh tester, hit load. As soon as we log in, we're just going to hit 4 and start zapifying everybody. Perfect. Cool. I'm going to call that one solved. So basically, we did what we accomplished, showed off all the different NavMeshAgent improvements, and proved that our object pooling is giving us some advantages in terms of the fact that we're not lagging nearly as badly. I might improve that in the future by separating the combat text onto different canvases for each object, but that's something I'll have to play around with to see if it's actually like really worth it, and try to get a handle on my frame rates and see if I can get some better way of showing those. I actually want to add a frame rate display to the game. So I hope you enjoyed that. As always, if you did, then don't forget to thumbs up the video, subscribe to the Cohesion YouTube channel, or just leave a note in the comments letting me know. Thanks so much for tuning in, and I will see you next time.